self-pollinated crops like wheat, it can take 6 to 7 generations to reach homozygosity or to create a pure line. And it's these pure lines that are released to farmers. So in other words, what we plant breeders do is cross one line with another to create what we call an F1. That F1 is grown out and it's an F2 generation. We then select individual plants from that F2 generation based on the different traits that we're looking for. It might be disease resistance or maturity or height. And then we allow them to self. We do the same thing in the F3 generation and onwards we go for about 7 to 8 generations. By that stage we have reached homozygosity. Now think about it. Each generation is a year in the field. That's a long time to make a homozygous line. We then take that homozygous line and we test it broadly in the environment over years for yield and quality and disease resistance before that is ever released to farmers. Now what double haploidy technology allows us to do is to jump to homozygosity, complete homozygosity in one single step. So in a 12-month period we can go from the cross to actually having seed of that homozygous line in our hands. That saves us an enormous amount of time. So what is the process? Well, we make an emasculation of our target plant and then we pollinate it not with pollen from wheat but pollen from maize. So in other words, we trick the wheat plant into thinking it's been fertilized and the embryo starts to grow. But of course in time those maize chromosomes are eliminated and the embryo will shrivel and die. That's why we rescue the embryo and we grow it on media. And I've got some examples here of those embryos growing on media. And of course these only have half the number of chromosomes. So these are what we call haploid plants and they're sterile. Now once that haploid plant has grown on and been transferred to a pot, it is completely sterile, remember. We then treat the roots with colchicine. And what colchicine does is double the chromosomes. So we now have a fully fertile plant with a balanced meiosis. And this is our double haploid plant. Normally it takes 12 years or more to produce a wheat variety. With this technology, we can cleave up to 5 years off the process and we can go to the farmer with a new variety with enhanced traits within 7 years. That is a phenomenal advantage to we breeders of self-pollinated crops. The other issue that I didn't raise is the combining double haploidy with other technologies like molecular markers. So for example, we can screen our F2 generation using molecular markers for known traits. Once we identify a plant that has the traits that we want based on those molecular markers, we can then send that for double haploidy and go to rapid fixation in a very short period of time. And that gives us a line with all those key genes that we want very, very quickly.